Assalamu alaikum students. Welcome to Cambridge Companion, and this is a new video. In this video we will do chemistry ASNA level paper 2 variant 22 October November 2024. Alright, so here we go. Question number 1. Um, State what is mean by uh, ground state. What is mean by the ground state? We all know that what is mean by the ground state. Lowest energy state. Okay, lowest energy state. All right. So another part of this question is show the electronic configuration of vanadium using electrons in the boxes. In the question above, this then the shorter electronic configuration of the vanadium in the ground state is Ar3d 3 and 4s 2. It means that three electrons with half filled will go anywhere in the boxes, but we have the two electrons in the 4s shell. Okay, s contains the two electrons, so here and mm, right. I think it's not this moving, not removed. Just make it, and I think it's not raw perfect use. As you know, sometimes it uh, be a problem for when you write. This is not the correct way to draw, but you know how to draw it. All right. So here we draw. Okay. How many reduce the total number of electrons on the p subshell of a vanadium atom? Um, we can write 1s2, 2s2, um, just write it here, 1s2, 2s2, what we have the vanadium atomic number is 23, so first we fill 23. Okay, 2p6, 3s2, how many electrons we have done with the 6 8 10 plus to 12, 3p6, 3D, 10, 12, 18, 5. All right, but this is not the case. Just we I draw for you for the electronic configuration. But the question what is asking? The question is asking, did use the total number of electrons in the p subshell. This is the highlight. This is the p subshell. So how many electrons we have p subshell? 6 in the 2p, 6 in the 3p. So total 12 electrons. Okay, I am removing all of this. So 3p is which we get 12 electrons. We have with 12 electrons. All right. Okay, now something easy question. The part B. um, the question is, fallopian was the suggested name of the new element discovered in the mineral. Fallopian was later found the mixture nobium and B and a titanium, tantalum, Ta. Only the naturally occurring isotope exists of each of Np and T. Okay. Uh, this is the isotope. This is the relative isotopic mass. What is the number of protons? It's so easy. Uh, we can see here clearly we have 41 protons. All right, we have 41 protons. And how many neutrons are there? You know, the mass number minus atomic number, you will get the number of the neutrons. So we 93 uh, minus 41, we get 52. Number of neutrons is 52. Okay, now how many protons are there? There are 73 the protons. And how many neutrons are there? Just simple, 181 minus 73, you will get 108 neutrons. One hundred and eight neutrons. All right, so it's a very simple question. Now move to the part 2. Define the relative atomic mass. So here we have relative isotopic mass. Okay, relative isotopic mass. Definition: a mass of an atom. Mass of an atom of an isotope compared to the just compared to the compared to the carbon 12 atom. Now move to the next part. A sample of fallopian contains 90.9% by mass of this element Nb9341 and 9.1% by mass of this element Ta with 18173. Okay, calculate the theoretical relative atomic mass of the fallopian based on these data in table 1.1. Okay, so we all know that what is the value of 90.9%. It means 90.9% divided by 100. We will get we will get mm, 0 point sorry 0.9. I think it's not working with the okay 0.9 0.9 multiply by 92.91. Here is 92.91. 92.91 plus 'We all know that 9.1% means 9.1 divided by 100 and we will get 0.091 0.091 multiply by what is the value? I think 180.95. 180.95. 80.95. All right. So what we will get after the multiplying 0.909 multiplied by 92.91, which is 84.45 plus 0.091 multiplied by 180.95, we get 100 and 100.92164. So we just say 100.92. Sorry, here we think it's sometimes it's difficult to write through this. All right, so it is 100.92. So now move to the next part. Next question. The next question is oxygen is a group 16 element. Okay, we all know that, right? The equation for the following is sodium with oxygen, right? Sodium with oxygen. What we will get? Na2O. This is the product, is sodium oxide. I think yes, Na2 was the only product. But we should balance the equation. All right. So I think uh, it should be draw something distance away, because some number will be added to the right hand side or left hand side. So Na2O. So we have, so we must add to 2 to this side, but we have to 4 this side. What about this? 4Na plus O2, which become 2Na2. Alright, I think this should be a balanced equation, because of 4Na, 2 2s are 4Na. There is 2 oxygens and the 2 oxygen. Okay. What about the sulfur and oxygen? Sulfur plus oxygen. What we will get? With sulfur dioxide, SO2. We can also get the sulfur trioxide, but it's for time consuming, so we just draw sulfur dioxide. Balance the equation. It is a balanced equation. Okay. Okay. Draw a dot and cross diagram to show the species present in the aluminum and oxygen. Draw the outer electrons. Okay. Aluminum can lose 3 electrons. Sometime, this. Uh, and oxygen, about O. Oxygen will gain 2 electrons. So here we draw, I am just making in the correct manner. So move to the next part. The maximum oxidation state uh, of the period 3 element elements in their oxides varies across the period. State and explain the variation. We have right the text mode. I think it's increase. It increases because the number of valence electrons increases. All right. Part B. Part B. Part 1. H2O means water reacts with both inorganic and organic compounds. Okay. Complete 2.1, table 2.1 to give the details of the reactions of the sum period of the three oxides with the H2. Okay. It means period 3 oxide which is magnesium. Okay. The period 3 it must be a magnesium oxide because we have the product of the magnesium oxide. So period 3 oxide, what is magnesium oxide, MgO. So pH, I think it's not acidic. So pH is between 8 to 12 or 8 to 10, 8 to 12. I think it's a suitable pH because it's not an acidic. But what about the phosphoric oxide? So what with the product with react with the water, which I think phosphoric acid. So H3. This is the V22 Q4. Think PO4. It's acidic. It's between 1 and 4. But what about this? Write the equation for the reaction of the CH3CN with H2 in the acidic conditions. So what is the product? It's a cyanide and with the water, and so it must be a carboxylic acid, CH3. Uh, COOH means a carboxylic acid. And we got ammonia as well, NH4, ammonium ion. But balance these thing to think for high. I think it's here too. Here is one, and I think it's completed. Alright, we move to the next part. Draw the structure of the two alcohols formed in the reaction between reaction shown in the equation. One, um, equation one. 2 alcohols formed by this. So we all know that we have to just draw it like this. We have the 3 carbons here. because of this. So we get there's 1, 2, 3 carbon, and one is the group of the alcohol like this. Sorry, make it clear. I think I should draw it clearly because it's not difficult to draw this type of diagram. I think. And another structure might be suggested, something like this: 1, 2, 3 carbon, and like this. Positive alcohol, the primary alcohol, the secondary alcohol. Okay, but what about the next part? Explain why um, alcohols are less acidic than water. Um, because alkyl groups are electron donating. Because are electron donating. Okay, and strength between the uh, strength of the OH bond, um, strengthens OH bond and which makes which makes H ions less likely to be donated. Less likely to be donated. Right. So move to the another part. Part C. Figure 2.1 shows the boiling point of the H2 and the other group 16 hydrides. Explain the trend in the boiling points of the group 16 hydride H2S to H2 and from this to this, from H2S to H2TE. Okay. From H2S, from H2S to H2TE, they have greater number of electrons. They have greater number of electrons. Oh, I think it's electrons. Stronger instantaneous or dipole and stronger instantaneous dipole and induced dipole. All right, this is the reason, or you can say the strong van der Waals forces. Okay, this is the reason. Explain why the boiling point of the H2O is much higher than that of the H2S. H2O has hydrogen bonding because you know H2O H2O has hydrogen bonding. Hydrogen bonding. All right. So here we done, students. With question number 1 and 2, and the remaining question we will do in next video, inshallah. Okay. Thank you. Allah Hafiz. Please like my video and subscribe my channel. Okay. Thank you. Allah Hafiz.